Okay, hey folks, I want to record this video getting into a little bit more specific information and detail on the free energy. So there's a couple scenarios here described by Atkins that I think describe this really well. And so this should be a pretty short little description, but will give us insight into what this free energy is. So we have our system here, and the game we're going to play is, could this system still undergo a spontaneous process in which its internal energy decreases and its entropy decreases? So we know right there that we've met one of the criterion for spontaneity, but this is not the correct criterion for spontaneity. So we have to investigate what's going on. And to do that, we remember for a spontaneous process, the free energy must be less than 0. In addition to our other qualifiers there. So we're going to talk about this with respect to the Helmholtz free energy, but we could play the same game with the Gibbs free energy as well. So looking at our definition of the Helmholtz free energy, which states that delta A equals delta U minus T delta S, and we recognize that is another way of saying work, the maximum work that we can do. So if we have the scenario in which delta U is negative and delta S is negative, what's going on here? Well, if delta S is negative, then a negative negative makes this quantity positive, and that means overall the absolute value of the quantity delta U minus T delta S is less than the quantity of delta U itself, right? So in other words, the amount of work that we can do is less than the internal energy we have in the first place. And I'll put those in absolute values. We recognize the work is negative because the system is doing work on the surroundings, but just to make sure that we can see that that's clear. Because of, again, the negative sign here, negative negative makes this a positive. So overall, the amount of work we can do is less than the internal energy that we have. And in order for this process to be spontaneous, a large amount of heat must evolve out into the system. So that difference in work less the internal energy is the heat that has to be evolved out into the system, which will cause enough increase in entropy of the surroundings such that the change may be spontaneous. So in other words, now the absolute value of the entropy change of the surroundings will be greater than the absolute value of the entropy change of the system, such that when we add them together, overall delta S total is still increasing. Okay? So Atkins describes this as nature is demanding a tax on you as it is converted into work. And that tax is the large amount of heat which must evolve out into the surroundings in order to generate enough entropy changes to keep this process spontaneous. Okay, how about another scenario? Well, in this case, in this scenario, we still have internal energy decreasing, so that's good. And we have the change in entropy increasing, so that's also good. So at first this appears like a slam dunk, but let's go ahead with this scenario so we can see the details. So once again, delta A must be negative. Looking at the relationship of delta A, we can see that that's delta U minus T delta S, which equals the maximum amount of work that we can do. And now noting, because delta S is a positive here, that tells us the quantity delta U minus T delta S will be greater than delta U. Or in other words, the work that we're able to do is actually greater than the internal energy we have in the first place. At first, this seems paradoxical, like how could we do more work than what our internal energy will provide? And now, in this case, nature is providing a tax refund. So in other words, nature is allowing heat to flow into the system, which may also be used as work in order to generate more internal energy than we had in the first place. And of course, once again here in this scenario, delta S of the system, the absolute value of that, must be greater than the absolute value of the entropy change in the surroundings, such that delta S total is a positive quantity when we add these two things together. And of course, we can see why delta S surroundings would be decreasing, because heat is flowing from surroundings to system. Okay? So hopefully that makes good sense. The free energy, we can think of it as either a tax on you as it's converted into work, or we could think of it as a tax refund from nature to give us enough internal energy to do work in a spontaneous way. So it's not free. We don't get this energy for free. It is a tax. Okay, hopefully that makes good sense. I will see you in the next video.